Good evening, everybody. My name is Travis Widerski. I'm here with Miller Electric. Thank you for joining our kickoff of the Aluminum Shop Talk Live series. So we're going to do a little bit of an introduction to the series tonight. Hopefully you guys have seen some of the information coming your way that we're going to be doing an extended series on different processes and problems that we see within the entire realm of welding aluminum. So it's a topic that we see over and over again. We get a lot of questions about. So we're going to cover some information throughout this series, all the way from absolute building block basics of aluminum prep for the fill of material, all the way through some advanced production type of information along the way. We've got a panel of different specialists from around the business that focus on different things, TIG welding, MIG welding, some advanced processes. So we're going to talk to those people here coming up. But again, that's what this series is going to be. Anything that you guys have that's a specific aluminum question, process, something that you want to see or have very specific information you want to get from us. We've got the email. It's going to be the shoptalklive@millerwelds.com. That's going to be a resource for you guys throughout the series where you can contact us, and maybe that will be one of our future topics. So feel free to use that. Tonight in the chat, hopefully we can interact with you guys a little bit along the way. Again, this one's going to be more of an introduction to who we are and where we're headed, but we do want to get some questions answered for you guys if we can as well. Because again, we've got 130 plus years on the panel here at Miller Electric, even more than that in industry. But again, we're going to introduce everybody here tonight. In future episodes, we're going to do some live from the shop, some live welding demos, and go through some different information for you guys on, again, different problems that we've heard come up again and again. And we're going to cover why those problems exist and how we can help you fix them. So to get started, one of our first presenters that we're going to meet is going to be Andrew Fowler. He's one of our TIG welding specialists. So Andrew, you want to kick us off on who are you, where you've been in the business, and kind of what you're going to cover throughout the aluminum series?
Sure. Thanks, Travis. So as Travis mentioned, my name is Andrew Fowler. I'm a segment manager with our TIG System Solutions division here at Miller. So I've been in the welding industry for over 15 years, and with 10 years being specifically here with our TIG group at Miller Electric. Started off as a weld engineer, moved my way up through doing different product development, and had the opportunity to see a lot of different applications, a lot of different problems, and been able to help solve a lot of different problems along the way. And really what we see when in the TIG welding space, particularly with aluminum, is that it starts off, a lot of people come from maybe like a MIG welding space, and with TIG welding, there's a lot of different factors to consider. If you think about, the process itself, you have in many cases a foot pedal or a fingertip control to control your amperage, and then you have your torch and your filler metal, and you have to coordinate all of these different elements in order to create a sound weld. So the entire time you're moving along your welding joint, you are reading the puddle, and you're trying to watch what's going on, and it's just a concert of a lot of different factors that a welder needs to take into consideration.
So the TIG welding side, we get a wide gamut. So we get a ton of people out there. I'm sure a lot of you guys that are watching tonight are just getting started TIG welding aluminum. We're going to start with some of the basics on your end, but then you've also had some of the experience and some of the really high-end customers too, right?
Yeah, certainly. And so kind of if we look at both ends of the spectrum, if we start off with the more basic element and the fact that aluminum welds differently than steel. So if you think about just the actual properties of the aluminum itself, there's an oxide layer on the surface, which certainly brings in, the difficulties in reading the actual welding puddle. That oxide is actually quite porous, and so it can hold a lot of different elements like oil and grease and different contaminants into that, which makes material preparation, which we're going to talk about in one of the upcoming series, certainly a major factor in the success of creating a good weld on aluminum. So, and as you mentioned, all the way from the basics there, all the way up through, some of the different advancements in the technology with, the change from transformer products back, from 40 years ago to the inverter products that we have today. And those inverter products have a lot of different um, adjustments in them that can not only help a beginner user, but also allow the more advanced user to fine tune their operation. Yeah, for example, the aerospace industry, where they're trying to get the highest quality welds, they're going to want to stack the cards or stack the deck in their favor. And so they're going to want to be able to make adjustments to the product um, in order to get the highest quality weld for their application. So I really look forward to this series and working with the different questions that come in along the way. Uh, Definitely excited to see some of the some possibly new questions, and hopefully the main thing here is answer questions for people that that they may be struggling with.
Right. And like you said, one of the first upcoming series that we're going to have is going to be next week. Andrew and I are going to cover some of the extreme basics of material prep. So Andrew said, the oxide layer, that's one of the very basic things that makes aluminum perform for a lot of the things that we want, the corrosion resistance, things like that. But if you look at it, that oxide layer looks like a bunch of fingers under a microscope that just want to grab all kinds of contamination. And it's extremely hard, and it's at a lot different melting temperature than what the aluminum does on its own. So even though it gives us a lot of the things that we like, it's definitely a consideration that we need to get rid of. And as we look later on into the series, later on into the year, with some more of the advanced TIG welding side, that's going to be something that you'll see Andrew again covering, a lot more. That's the in-depth side, what you might see in that high-end aviation customer, or, some of the fabrication production type of industry that's out there. So again, hopefully we've got a wide gamut of people watching. But again, if you've got comments, questions, things like that, you can throw them in the chat. You can email us those so we can cover them in future episodes. Whatever you guys want to see, hopefully we can keep it as interactive for you guys that we can. Again, in upcoming events, we'll have the opportunity to go live from the lab, look at some of the equipment, depending on what you're looking for. So make sure you guys reach out to us. Let us know what you want to see so we can tailor this setup to truly what's going to be beneficial to you guys. Because again, we want to cover the whole spectrum. We want to make sure we have information out there for the extreme beginners. And then hopefully by the end of this, we've got some really good information for you, those of you who have been welding for years and are on a plant floor type of scenario as well. So another industry that uses kind of a wide gamut of what we're covering here throughout the aluminum series is going to be the motorsport. So thank you, Andrew. We're going to transition over to Andy, who is one of our specialists that's coming from more the motorsports performance and aftermarket background. Andy, do you want to introduce who you are and kind of what you're going to be covering throughout the aluminum series?
Sure, Travis. Thanks. Yes, I'm Andy Weinberg. I've been with Miller for about 32 years. The last 22 years has been in the aftermarket performance and motorsports industries. Those industries do use a lot of aluminum, and I'll be working with different alloys and talking about fabrication techniques, some of the best welding applications, as well as maybe even some filler metals that work best in certain applications. I'm also going to work with some of the beginners and kind of show some of the exercises that I like to teach my beginners on to get them more calibrated in their head with the whole hand, eye, foot, adding the filler metal. I've got some exercises that I show my beginners that help them fast track their training and, helps really eliminate the need to make a lot of scrap right off the bat. A lot of people will tell you, hey, go ahead. It's just about practice, practice, practice. You just got to get under the hood and just keep trying it. But let me tell you, you don't have to make a pile of scrap right away, because each hand is doing something different. Your foot is controlling the power of the machine, and your eyes really have to be in tune with the weld puddle. Just like Andrew Fowler said, puddle control is everything when TIG welding aluminum. So I've got some exercises on that.
Yeah. And one of the things, to note there, Andy, for the extreme beginners, some of those initial setup problems, like you said, if you're not great on your rhythm, the tungsten and the TIG side is going to be something that's not truly going to be considered a consumable. But the minute that you have an issue, you touch your filler metal to that, you touch it in the base material. For most machines, that's going to end up on that tungsten. And from there on out, that's going to be a very simple problem that if you don't take care of it, is going to make trying to weld aluminum much more difficult for you right from the start. So some of this stuff, again, that we cover for the beginners is, for those of you who've been in industry a long time, are going to be some of the basics, but we'll set them up that way. So we're taking the series from a basic view, and then we'll have some advanced classes as well. But, for some of that, like your aluminum getting onto your tungsten is going to be something that's a problem from the beginning that if you don't take care of it, you're going to see all the way throughout and set yourself up for failure versus success right from the beginning. So some real simple stuff there that we can help out with as well.
Sure. And one of my simple rules of thumb for tungstens, I mean, even sizing your tungstens is, really, a good rule of thumb for that is don't use a tungsten larger than the thickness of the base metal that you're using, because the tungstens actually have a window that they work best in. And that applies also with your filler metal. Don't use a filler metal that's also thicker in diameter than the base metal you're welding, because you have to apply more heat to get that filler metal to melt in properly. And by that time, you're overdoing the heat that the base metal can handle. I'm also going to be showing some of the machines that we'll be using too, starting with some of the beginner machines that I would classify maybe a beginner, but still has some advanced features like the Multimatic 220 AC/DC. And I've got some different camera views. So one of the things I love about this machine is it has an auto set feature even for TIG. So really all I need to do is tell it the tungsten size and the material thickness that I'm welding, and the machine automatically puts you in a range. And then as you get more fluent with those types of settings and you want to set those things manually, you can take it out of auto set and then control those things manually, but you also open yourself up to 2 other additional settings, which is your frequency and your balance control. And we'll talk about those in future segments as well. But I guess one of the other things that I want to say about aluminum that's, a lot of people, even in the performance industry, think that they should use some of the strongest aluminum for their projects. And sometimes that's not the case. Unlike steel, where steel, even your higher strength steels can be formed in a brake press, or you can fabricate it, bend it, roll it. With aluminum, that's not necessarily the case. And a good example of that is just using different alloys. Like 6061, for example, is a very strong alloy of aluminum, but as soon as you try to bend it, and this one's being bent at a 90 degree, you can see that it's already formed a crack. So even though 6061 is an extremely strong aluminum alloy, it's not good for bending and forming applications. So in that case, I would go to like a 5052 aluminum. And this aluminum bends and is still quite strong. This is a 90 degree bend. This is 120 degrees off the same alloy. So the strength considerations and selecting the proper alloy in this industry is also critical. And that varies even by temperature application. So, and whether you're working with something that might be under pressure. So here's an aluminum, this is actually a power steering reservoir that I make for our race cars. It's made out of 3003 aluminum alloy. It's easy to form. It's easy to weld. I can put bead rolls in it. It's also compatible with 6061, which these bungs are welded on here with 6061. But again, picking the proper filler metals for these type of applications are critical.
And that's something Galen will talk about a little bit more coming in too. But one of the comments that we had early on was, I hope we're using some of the dynasties and things like that. So hopefully not a letdown tonight. Again, this one's going to be more of an intro, but definitely in future episodes, that is exactly what we're looking to do. So for any of you, again, that are out there that have suggestions, questions, comments, concerns, something that you see every day and deal with, let us know. That Shop Talk Live email that's going to be in the chat. Make sure you guys reach out to us there. Hopefully we can tailor some of this stuff for your exact issues and problems. If you guys have extremely detailed problematic scenarios, that might be something that we direct back internally to the welding engineers within the business unit and try to get you some help that way. We might not necessarily answer those completely on future episodes, but again, we're hopefully still able to get you a resource to get an answer to those questions and help you out on why you see those issues. So definitely more to come on those machines. Andy, we appreciate your look into a little bit of the fabrication side of things as well. I think that's going to be something that a lot of people are hopefully looking for, as one of the basic building blocks, but even getting a little bit more advanced. So as we continue on, thank you, Andy. We're going to go over to Chris, who's one of our guys who specializes on the MIG welding side. And more the home hobbyist light fabrication side of things is where he spends a lot of his time. So Chris, do you want to introduce a little bit more about yourself and what you've done with the company and where you've been?
Sure. My name is Chris Rail. I have been at Miller Electric for 34 years. I spent half my career out in the field. I went to a lot of facilities for aluminum applications, building trailers, boats, transportation, military. So as far as being out into the field, seeing how people are using machines at all these different levels, I had a good opportunity to go work with those, understand their pain points, and see what we can do to make products that will address these pain points and make their welding processes better. For the last 17 years, I have been back at Miller Electric as a product manager for our Miller-Matic divisions. And so I've talked to a lot of people over the phone. I've gone to a lot of trade shows talking about these products just to see what kind of issues they had, always trying to help them optimize the performance when they're using our machines. But a lot of the questions that these people ask about is using our machines to weld aluminum, or the basics aluminum MIG welding questions. So during the episodes that I'll be talking about, our basic aluminum episodes, is we're going to be talking about some of the basic questions that we get. I do some demos. So for example, one of the questions we typically get is, can I use a MIG gun to weld aluminum? Typically my response always is what's your tolerance of pain? And the reason being is, typically people always use a MIG gun for welding steel, but the steel wire is very stiff. But aluminum, I think a lot of us know, is very soft. So if you try pushing aluminum through a standard MIG gun, the analogy I use, it's like pushing a wet noodle through a straw. It's very, very difficult to do. So not saying you can't do it, but we typically don't recommend it. So
right.
when you're welding,
that's some of the information that we want to pass along as well. So that's a question. I know I've been on the road a lot with Chris, and we get that a lot, is can I run it through my standard whip? And to tell you that you can't take a shorter gun and put a Teflon liner in it, something like that, that's going to be information that, yes, you can, but expect feeding issues. So, again, we're not going to be here for a sales pitch to, tell you that you have to have a push-pull gun or an MPA system for everything you're doing aluminum. We're going to answer those questions for you accurately. So like Chris said, is that something that you can do? Absolutely. Is it the best way to do it? Maybe, maybe not for your application. It all depends. So again, we'll try to answer any of those questions as honestly for you as we can, from the technical side and problem solution side.
Right. And, it's definitely, depending on your alloy you're using, your wire diameter, your application, all these different types of guns you could use have their advantages and disadvantages. So again, understanding your situation, how you're using it, there's, multiple options that you can use. Other question that we typically get is, what type of machine or how big of a machine do I need to weld aluminum? There's so many machines out there. There's 120 volt machines, 240 volt machines, 460 MIG machines, pulse MIG machines. What ones do you need? We'll cover, the different processes, but typically for welding aluminum, you want to be at a minimum of spray transfer because that's a hotter process that will be able to penetrate into your base material and give you good fusion. So, we recommend, starting with the 240 volt machine or up. There are other machines out there like 120 volt machines that, say they can do it. They have spool guns to do that. But typically, it doesn't really have the power that you really need. There's some applications maybe that you can use thinner gauge material. But again, as far as what machine, what process for welding aluminum, we'll be talking about those in further episodes also. And the
what
other
size
one is
machine?
Size machine, right? So, and then the other one is a lot of people welding aluminum. They have when they're done welding, their weld appears to be black, and they get very frustrated. And a lot of times when people they think are very good steel welders, but a lot of the techniques and the processes that you're using there really don't carry over to aluminum. So, for example, a lot of times you can't, for welding aluminum, you can't use the same shielding gas as you do for your steel applications. You have to use 100% argon. So we'll talk about, what happens if you use the different gases in the future. There's other variables like Andy and Andrew were saying, the aluminum oxide, you have to make sure you clean the material before you weld it. Also the proper, gun technique, again, with MIG welding, you can either push it or you can drag it. For aluminum, we recommend it with push technique, and we'll talk about that in the future also as far as why we recommend using those processes.
Right. So not only will we try to kind of convey why we need to do some of these steps, again, we're going to cover a lot of the mistakes and missteps that we see along the way, and try to give you insight on why that makes a difference. And some of it may, like Chris said, if you got a black weld, it might be as easy as changing your gun direction. It may be something that's very specific to the filament material, which Galen will get into a little bit later. But Chris is definitely going to be one of the major resources from kind of the home hobby all the way up to even a lot of the newer machines that have the pulse capability for a lot of the new aluminum body repair type of facilities as well. I know that's something that you cover as well, right, Chris?
That's right. Yeah. So now, as far as we talk to home users, customers in the light manufacturing, fabrication, auto collision repair, that's definitely becoming a very aluminum focused market. So yeah, we'll be talking about those future products in the near future.
Well, thanks, Chris.
Yep.
One of the folks on the presentation that I didn't introduce is James. He's kind of our behind the scenes. He's our contact from the chat function to from you to us. So James, do we have any questions, any comments, concerns that we want to cover before we keep going here?
I don't think we have anything that needs to get covered on stream right now. We are getting a lot of good questions, good engagement here in the comment section. So glad to have you guys join us here tonight for this live stream.
Excellent. Thanks, James. And again, like he said, anything that you guys have that you want to see in future episodes, please shoot that to the email James has got there in the chat. We want to make this as beneficial for you guys long-term as we can. And again, as you can see going here tonight, we want to keep it kind of as informal and conversation style as we can. So if you guys have questions, feel free to throw them out there. We'll cover what we can tonight. If not, hopefully we can cover it in a future episode. So as we keep going here, we'll talk to Cody. He's going to be one of our specialists that's been with Miller for a little bit longer period of time, but he's definitely got more of the technical background. I know, Cody, you spent a lot of time with more of the advanced processes and more of the fabrication and industry type of customers. So you want to introduce who you are, what your background is, and kind of what you deal with on your day-to-day.
Sure. Thanks, Travis. My name is Cody Welch. I am a welding engineer at Miller Electric. I've been with Miller as a welding engineer now for about 17 years. Most of that time has been spent in the welding labs, supporting equipment that you guys see and use every day. Some of the equipment maybe you might recognize would be XMTs, MPAs, Envisions, Delta welds, arc reach, continuums, anything that really serves our large industrial base as well as our large end users out there, infrastructure, for example. And one of the things is as I worked on the shop floor, not shop floor, but in the welding labs there at Miller. Now I'm in the marketing group. I'm a weld engineer in the marketing group, where one of my roles is to try to help bring information out to our customers about the equipment, how to use it, so you guys can get the most benefit out of it. One of the common questions we would get is, especially with aluminum, would be, what kind of equipment do I need? What do I choose when I'm looking at equipment? When we get that call or that question coming in, and the customer's decided what process they want to use, and in this case it's MIG. One of the first things I'm really going to ask that customer is how much aluminum do you do? Are you an aluminum only shop? Is that all you deal with? Are you just building aluminum boats? Or are you a shipyard, doing aluminum? Or are you maybe a multi-material shop? Maybe you're building some sort of tanks, et cetera, things like that. Maybe you're running stainless and aluminum in your shop. And what that answer comes back to be is going to influence which direction I steer you to try to get you the best value and a solution that's going to work the best for your applications.
And to go a little bit further than, whether it's dedicated to aluminum or a system that can do both. Talking to Chris, a lot of his market in customer is, do I have 120 capability? Do I have 240 capability? As we start getting into the more advanced side in the industrial customers that you deal with day to day, a lot of times power is not necessarily as much of a factor. It can be a little bit, but a lot of times that true separation comes down to different process transfers and
Right, yep.
Some advanced features on these machines that's really driving you to that, right?
Yeah, that's right, and that's spot on. A lot of our customers, they're looking to move towards pulse. They want to understand the value of pulse. One of the roles of weld engineers at Miller is we build the pulse arcs that go in the machines. We enter the pulse data in there. We're going to talk about that a little bit here. But as we're talking to our customers out there, sometimes we'll ask them what kind of transfer are you running when they're getting into certain circumstances. They might be running aluminum in what's called a short circuit transfer, and that's generally not what we want to be running aluminum, and that can lead to a lot of problems. And when we start having some of these discussions, sometimes they don't know what I mean by what a transfer mode is, and there's different transfer modes when we're running MIG. There's short circuit, there's globular, there's spray, then there's pulse. And then so I might guess, well, what is pulse? And really what pulsing is we're using machine, we're moving a waveform in the machine, certain variables of data that we'll get into this discussion. And what we're going to do is we're going to move that data to start pinching droplets one at a time as they come across that arc in a very controlled, precise manner. And the way that happens is we go into the machine and we have certain tools in the machine where we control how we want that power supply to apply energy to that wire. So we can control how that wire is dropped, how that arc cone is shaped, how long the arc length is, how the arc reacts to the puddle, et cetera. And there's a lot of variables in it, but really the basic ones when we start talking about pulse parameters, pulse data, you'll hear it's called pulse data a lot. Really there's four main drivers there, and those are going to be our peak currents, our background currents, our pulse width, and our pulses per second. And by manipulating some of that data there, we can shape how that arc cone is. We can affect how the puddle fluidities work. We affect how that ball transfer comes across, and we build that arc to go out so that when it goes into our customers' hands, it's functioning in a manner that they would expect from us.
And that's something too that as we look into the shipbuilding and all these more advanced type of customers that are truly building a very specific arc for a specific reason, we have multiple different types of pulse as well now, that it's not just a pulse program. So we're going to cover even more with that, right?
Yeah, there's lots of different types of pulse. For our aluminum users out there, I would say probably most of our aluminum users are most familiar with our MPAs, which is a constant current pulse. When we look at other equipment, we get into like say continuums or maybe the old Access machines or even the new Delta Weld that's out there. We have AccuPulse, which it's using some of these variables, but it's also got different things going on behind the scenes, and it works a little differently. But at the end of the day, for our end user, it's still about that single ball droplet coming across that arc in a very controlled manner so that that welder can control that puddle and steer that puddle as they need to.
Right. So again, for even the advanced customers, hopefully we've got some of you out there that, again, if you have a very specific problem that you see day in and day out, or, a lot of times those customers don't realize that they have those issues as much as they do because they've learned to work around them. You get those really skilled operators that are becoming much harder to find, and these types of processes are going to help with some of that, right, Cody?
Right. Yeah. These kinds of processes are going to help with that, and the way we control the machine. So that's another question we get a lot is what do these knobs on this piece of pulse equipment, what are they doing? What is arc length? What is arc adjust? What is trim? Well, the answer is they're all the same thing, whether you call it arc adjust, arc length, or trim. What that is that's a knob. On this picture you see in front of you, that value would be 50, and that value just is more or less an arbitrary value. If you go to 55, that means that arc length is going to go up. If you turn it down to 40, that means that arc length is going to get closer to the puddle. You'll see more shorting. That's what the arc length controls. We also have another control in there next to that. You see that there. That's our wire feed speed. Most people, they're going to be pretty familiar with that. Then there's another control, the one that does the black magic. We probably get more questions on than anything, and that's called arc control. What arc control does is the way I describe it to customers is usually it's a fine control knob that I use when I need to get certain arc characteristics or maybe puddle fluidities out of an application. I'm going to tailor that to what I'm trying to do in an application. To your point of newer, new people coming into the trade that they're learning. Synergic. What is synergic, Cody? That's another question I'll get. What is synergic? And really what synergic is it's not very complicated. It's if I set a given arc length, and in this case, in front of you see it at 50, at a wire speed, that's going to give me a certain arc length. And as I weld along, it's going to keep that arc at that same length. Now, if I go to say a thicker piece of material, I need to increase my wire feed speed to get my heat up, get a larger weld puddle going, get more penetration. On our conventional, on the conventional machines, you would have to go now and make a voltage increase that is going to match that increase that you've made in your wire speed. With Synergic, we don't have to do that. With Synergic, the machine's going to take care of that for you. It's going to increase that arc length to keep you in a weldable arc. It's basically the way I describe it to people is it's a single knob control. Once you find an arc length you like, leave it there and just make your heat adjustments. If you want a hotter, more fluid puddle or a smaller puddle, thin to thick materials, just adjust your wire feed speed.
Right. And that's going to be a sliding scale that you still have a fine tune adjustment. It doesn't lock you in, even
Right.
kind of similar to what we saw in some of the more basic equipment with the auto set that Andy talked a little bit about. But again, for those operators that are out there with years of experience, we're not necessarily looking to replace you. Obviously that's a lot of experience there in the shop floor that, again, a lot of times you don't notice some of these issues that the new people coming in do because you've learned to work around it. So the name of the game was some of this newer equipment is to try to make it a little bit easier to control the machine so you can make it do what you want it to do. And like Cody said, there's a few different knobs to learn on the way. But even coming back to like the arc length, that's going to be your physical length from the unburned wire to your puddle. And whether you're going 100 inches a minute or 500, that machine's going to try to fight to give you that same length wherever you are. So
Right.
These machines have become a lot smarter than they used to be, when they were just some basic pieces of copper. So we got a lot of stuff we'll cover in that advanced side, the production side. So thanks, Cody. One of the things that's kind of common across the board, whether it's going to be the basics, the TIG welding, MIG welding, it doesn't matter, is going to be your filament material selection. So we've got Galen. He's going to be our representative specialist from Miller Hobart. He spends his day truly around the metallurgy side of things and what filler is the correct filler for your application. So Galen, do you want to introduce who you are, what you've done, and where you're going to be covering, what you're going to be covering within the aluminum series as we move forward?
Sure. Thanks, Travis. My name is Galen White, and I'm the aluminum product specialist. And I've worked for the Miller and Hobart team for about 23 years now. I started my career at Miller Electric in Appleton. I worked with Chris at the business unit that makes the Miller-Matics. And then in 2010, I transferred to the Hobart Aluminum Business Unit in Traverse City, Michigan. So I've been there for the last 11 years. And the last 7 years, I've been the aluminum product specialist for basically the eastern half of the United States. And the topic I'm going to be covering later in the series is aluminum filler metal selection. And this is a typical filler metal selection that I get. Someone will call me up on the phone and say, hey, Galen, I'm welding, or I've got a customer that's welding aluminum. What filler metal do I use? So I like to ask questions. And the first question I ask is, okay, what base metal are they welding? And usually the response is, I have no idea. So I'll ask them, okay, if you don't know the base metal, what is this going to be? Or how is he going to use it? I don't know that either. So in order to make the best filler metal selection, you need to know the base metal. And sometimes it's as easy as looking on the sheet and it'll be stamped on there, or trying to find the cert. If you don't know that, then you might have to dig a little bit deeper and call some people to get some certs. But once you know the base metal alloy, then you need to determine what the end application is, or what's important to the designer. So is strength most important, or is it an application where toughness, impact resistance is really important? Is it going to be an elevated temperature service application? Is it going to be post-weld anodized? Or is it going to be an application where you need to do some post-weld heat treatment? All those things factor into being able to pick the absolute best filler metal for that application. the good news is that if you're welding on a 5000 or 6000 series base metal, 80% of the time, either 5356 or 4043 will work. But we can help you narrow it down and find the absolute best filler metal for that application. Now, aluminum filler metal selection is a little more difficult than steel, I would say. A lot of times with steel, if you're welding just mild steel or A36, you're really looking at trying to find, ER70S6 or 6010 or 7018. But because with aluminum, there's a broad range of chemistries associated with the base metals. So other than the 1000 series of base metals, all other aluminum alloys are alloyed with either magnesium, silicon, copper, zinc, or manganese, or some combination of those things. So with those different chemistries, you can have different base metal combinations that may not be weldable. And even some of the aerospace alloys are not weldable themselves. So for instance, a 2024 or a 7075, they're used in the aerospace because they have really high strength, but they're considered unweldable with the arc welding process. A more common base metal would be like a 6061, and by itself, it's not weldable autogenously or without filler metal. So you need to pick the right filler metal based on the application. And there are probably 7 or 8 filler wires that you could use for welding 6061 that would work. But if you pick the wrong one and the wrong application, you could run into problems.
And Andy showed that even trying to form that with the crack in it, but just kind of as an insight for that, if I take it and I just run a weld down it with no filler material, what's going to happen to that?
Chances are it's going to crack. There's enough of the alloying elements that will end up in the grain boundaries that just the stress in the weld contracting alone will cause a crack to form. So, and filler metal selection too, and also base metal prep, sometimes if you're trying to weld a square butt weld on 6061, you'll still get a crack. But if you put a little bit of a bevel on it where you can actually get a little bit higher concentration of the weld metal or filler metal in the weld zone, you can get those cracks to go away. So one scenario where filler metal is very important would be, say for instance, you're welding 6061 to 6061, but it's going to be in an elevated temperature application. Say for instance, it's going to be in a hot asphalt type of container, and you didn't know any better and you used 5356. Well, 5356 has about 5% magnesium, and that's not recommended for use in high temperature applications. So it's possible that you could have some stress corrosion cracking during the life of that weld. Another situation would be the same thing, 6061.
Before you go on with that, Galen, so one of the things that I always find interesting, and typically when we're even teaching some of our basic stuff, that high elevated temperature for aluminum, I think, is a number that for most people is a lot lower than you would expect. I think high temperature, I'm thinking 800, 900 degrees, 1,000 degrees. What's that number going to be for aluminum?
It's a range. So it's anything between 150 and 350 F. That's the danger zone. That's when you need to really pay attention to the base metal that you use and the filler metal that you use. Below that or above that, the problems are not as critical.
So that's, but for anybody who's on, that's not necessarily have to be a scenario where you've got direct heat all the time. You can get to 150 degrees pretty easily in a lot of your projects. So sorry about in there. You can continue on, but I always find that number to be interesting.
It's surprisingly low for aluminum. Yep. So just remember the danger zone is 150 to 350 F. So another scenario that I get quite often is welding any 6000 series, so 6061 or 6063, and it's going to be post-weld anodized. So, whenever I'm traveling, I'll be in a hospital or I'll be at Disney World, and you'll see some handrails and the welds are dark. And usually what happens there is they just don't know any better, and they use a 4000 series filler metal. And because of the high silicon content, when they anodize them, either clear or gray, the welds will discolor much darker than the base material. So, in that application, you'd want to use a 5000 series. That's going to give you a lot better color match to the base metal. So, I would say on our filler metal chart, there's probably 80 base metals. There's probably 12 filler metals. So, it's kind of a complex process, but we have some tools that you can use. in the back of our Hobart aluminum guide, or we also offer some large filler metal wall charts. There's a cross reference that helps you kind of dial it in for the base metal that you're welding on. And then we also offer at no charge, it's called the Hobart app. And inside that app, it has an aluminum filler metal selection chart. So instead of trying to, get those lines or those blocks to line up, it does it through the app and makes it much easier to see. But we'll dig deeper into that in the future when we get to the filler metal selection part of the live stream.
And like I said, so there is a lot to aluminum selection. So a couple of things, from the beginner typical fabrication, we'll talk a lot about 4,000 versus 5,000, some of the basics and what they're used for. But, obviously sitting here listening to Galen, you guys are going to notice that there is a lot to consider when it comes to aluminum. What we want you to get out of that is the fact that we have people like Galen sitting, in Traverse City, or whether it's in Ohio, different places where this is their specialty. So just remember there's tools available. And again, you got questions, specific applications, email those to us and we'll talk about them in that seminar. But there's tools and there's people available where if you've got a critical project, something coming up and you want to know, maybe you don't know what the base material is. A lot of times those applications, people that deal with it every day, Galen can probably tell you what that base material is, based on if it's a boat motor in saltwater, what the application is, they can probably tell you what that base material is. So just keep in mind that there's a lot of resources out there, either through the apps, through the website, or through calling into guys like Galen to get that answer, because it is pretty critical. So hopefully there's a lot we can cover in that, and Galen could have hours and hours of seminars for us on the metallurgy side. So any questions, comments you guys have out there that are very specific to that, Galen's going to be our resource for that. And hopefully we can get those questions answered for you in different points in time with the aluminum series. So thank you, Galen. I think we'll go back to the group here. James, I'll see, do we have any specific questions coming in from those online?
I don't think we have a ton of specific questions. I think a lot of them I've been able to just answer here in the chat. There's honestly too many questions coming in to pick one or two that we could give to you guys, but we do have quite a few good questions coming in the chat.
Excellent. Well, again, for anybody who is on the chat, make sure you use that email that James has up in there for your specific questions, comments, concerns that you want us to talk about in the future. We've got a couple minutes here. We want to make sure we don't take up too much of your guys' time tonight. We do appreciate you guys stopping by and getting a look into the aluminum series and what it's going to be, what we're going to have a chance to cover for you. Again, we want to make this as interactive with our audience as we can. So anybody who's out there who's specific things you want to see, let us know. In a couple minutes before we take off, in our Brady Bunch screen here, anything that you guys that have that stand out as kind of your tops that we're going to cover, that you see day in and day out that we haven't covered yet tonight, that you want to make sure everybody online knows that we're going to cover coming up, or anything, real unique, anything like that you guys want to say, let them know about or cover before we jump off here tonight?
One thing I would maybe throw out there, Travis, especially when we get into pulsing, is our weld cables. Our weld cables and our grounding systems are probably one of the most overlooked, issues that go on out there, and within a customer's facilities, fixturing, et cetera, things like that. If we want to get the most consistency and reliability and quality, we really don't want to be we don't want to be skimping on our weld cables and our grounding. We need good connections. We need properly sized cables. And those are some things that we'll talk about when we get into the advanced pulsing.
Yeah, and that's a great kind of comment too, Cody, is the fact that everything that we're going to cover is going to be geared towards making welding aluminum easier for you guys in your specific applications, but those don't necessarily have to be, Miller-Matic or MPA related. If you guys have questions on some of the setup, like Cody said, on your fixturing, cabling, that kind of stuff, even if it's not stuff that we can answer directly in the seminars, feel free to email us that kind of information as well. And we'll try to get you solutions or the right people, the tools to answer those questions for you along the way as well. So any kind of challenges that you guys have, even if they're more technical, or more setup related, feel free to pass that along as well. Perfect.
All right, so we do have some questions here in the chat. We got one for Andy, I think specifically. How's the Firebird series coming along? A little off topic here, but
It's coming along good. Yeah, the roll cage is in. We're filming the next season already, so look for that stuff to be released here, I think, towards the end of February. We'll be putting in new firewalls. But yeah, quite a bit of work to be done on the Firebird. We also have some detour projects. Unfortunately, my old Jeep TJ here has some issues, so we had to do some fabrication on that. So we're actually going to have a little bit of that on the Real Garage series as well. And I also want to say too, even for our beginner aluminum guys, one of the things that even Andrew mentioned it, working with that puddle, trying to manage that puddle, unless you have somebody over your shoulder actually looking at what you're doing and trying to figure it out, it's hard to actually get to identify your own deficiencies in what you're trying to do, right? So I've got a weld camera set up. I'm actually going to do some arc shots. We'll actually be able to see the puddle develop. We'll actually be able to show you what you're looking for. So give you a better idea of what to see, and so that you can kind of duplicate it on your side. So,
and with that, I think we'll try to show for a lot of the people too of what it looks like when it's done wrong. We'll show you what that tungsten looks like with a big wad of aluminum on it and what it's going to do to your weld. And you don't have a prayer in making the stacked dimes once you have that going on. And that's some of the basic stuff where if you don't know it, you're going to fight it without knowing, So, a lot of stuff we can cover there, but like you say, a lot of it, for me at least, seeing it done perfectly isn't necessarily the most helpful. If I see what it looks like when it's done wrong, I can relate to that a lot more typically. So a lot we can do there. A good point, Andy.
We've got another question here from Ben. As a beginner trying to decide whether to get a spool gun for my existing MIG or switch to TIG, advice on how to decide.
I think one of the large factors that goes in there is, one, how much welding do you plan on doing? Do you have any experience with maybe like an oxy-fuel welding process that a lot of those techniques that you might say carry over with the hand-eye coordination with TIG, and then also the cleanliness of the material and what is the end strength requirements or quality requirements that maybe you're looking for. Certainly with TIG you can get a lot really nice looking welds, really high quality welds, but if you have an application where maybe you just need to get it done a little bit faster and don't want to invest the time into learning the ins and outs of a new welding process, then it may be a consideration and may be advisable to stay with a spool gun, because you're not relearning MIG weld. You are learning a different material, but it's a lot of the fundamentals of hand-eye coordination do carry over from MIGging steel to MIG welding the spool gun. Whereas if you switch to a TIG welding process, you're going to be essentially relearning, or you're going to be learning a new welding process along with learning a new material.
Yeah, I
a
think
lot of
like
that is going to be project specific as well.
Yeah, I'd like to piggyback on that too. It's a precision thing too. With TIG, you have a lot more precision. The control of the heat is infinite because you're controlling it. With MIG welding, you're kind of set at this, this area that you have to use to melt that wire properly, and you have to compensate by how fast you actually have to weld. So if you want precision and need that control, you're going to need to TIG weld it. If it's more of a, like Andrew said, a production environment or something that's non-critical, spool gun might be the way to go. I use them both. There's applications for both. Yeah. I'm primarily a TIG guy. I love TIG, but if it's just a simple project that I'm doing, I'll do it with MIG. If you ask me what my preference is, it's definitely TIG. There's a reason they don't TIG weld the space or MIG weld the space shuttle together, right? It's right. It's all TIG welding.
But to bridge that gap, kind of along both lines, yeah, you can have a lot more precision with TIG, but if you don't know the process, that precision's probably not going to be there from the start. So you're going to make a lot of scrap in the way there and learning it too. So, because if you don't travel fast enough, you're going to create more issues for yourself with the TIG welding side. So again, we can cover a lot of that information. If you got a specific project, something like that, email it to us and we'll let you know what kind of our standard thought would be. You know, spool guns spend a lot of time doing repair work because they're really good at it.
And we
But
do
again,
have,
if you're trying to do something that's paper thin and you're just learning TIG, not going to be extremely easy to learn right off the bat.
we do have one more good question here. I think this is probably a good one. Can you start with aluminum or is it better to start with steel when you're learning how to weld?
User preference, because a lot of people like to learn on aluminum. I loved learning on steel. So that is a very objective.
Yeah,
So let's pull the panel. What do you guys think?
Let me answer this way. For the same material thickness, you have to travel and when I'm talking MIG welding, for the same material thickness, you have to travel much faster with aluminum than you do with steel. So you would, in a sense, you would have to learn to run before you would walk. Whereas with steel, you can typically run that a little bit slower. That's my opinion.
I think for steel, for steel TIG welding steel is easier because the puddle is easier to see. It's more defined. It doesn't wander around. So TIG welding is easier to start with, I think, with steel. That's kind of my prep.
Yep. One thing I would throw out there, I guess, and we're going to get into some of this discussion in this series, I'm sure. But starting with steel will be easier to learn the puddle control. However, that understanding that aluminum is its own animal. There's some differences going on there, and there's differences in maybe the wire diameters we want to select for a given thickness now may be different than what you would normally have picked for steel of the same kind of material thickness. Again, the technique is going to be a little bit more different. Understanding the gas blends, your gun angle techniques. Now that's going to become a different factor in there as well. So it's easier to learn how to read a puddle starting with steel, but I agree with what you said there about walking before you run there too, Travis. I think you just want to be careful you don't start treating aluminum as you would treat steel as you're learning.
And I always had that debate with a lot of people that liked how big the aluminum puddle was TIG welding when we were learning. And, for me, the precision was easier. But one thing that is true across the board that's extremely difficult if you've not done aluminum in the past is you don't have that color change like you do with steel. If you're used to oxyfuel welding or TIG welding steel, even just fabbing steel in general, you're going to get that color change, gives you an idea where the temperature's at, whether you're going to blow through the back of it or not. Where aluminum, it goes from shiny to a little more shiny to it's gone. And to the people who could oxyfuel weld aluminum, I have the utmost respect because I've spent a lot of time TIG welding. I love TIG welding aluminum, and I don't have a prayer in oxyfuel welding it because you have very little to see that color change before it's perfect and then it's gone. So that not having that indicator is tough for a lot of people who are definitely used to fabricating steel and have never spent any time on the aluminum side. Excellent. Well, if nobody's got any other questions, again, we appreciate you joining us tonight for the intro, meeting the team. We're going to be, focused on fixing your problems, hopefully over the next few months, or, we can extend this to however long we need to cover all the topics that you guys shoot into us. But we're definitely going to look to step this series through some basics. Again, next week, Andrew and I are going to start out with the very basic building blocks of prepping the material, going through what makes aluminum different? What do we need to consider, even from cutting the material to prepping it to welding it, cleaning it, all that kind of stuff. Then we'll progress into some of the basics. So basic MIG, basic TIG. Then we'll start getting into some of the advanced MIG, advanced TIG stuff, getting more into the production side of things. We might even, do something specific to a lot of the different gamut and filament materials or robotics, different kind of things like that. Who knows? Whatever you guys have for questions, like I said, we'll kind of determine where we end up. We've got a lot of questions, again, that we see day in and day out over the years that we're going to know that we're going to want to cover. But if you guys have stuff that's specific to your application, your day-to-day life that you struggle with or would like to make better, feel free to email those, shoptalklive@millerwelds.com. we'll try to make them a topic, or we'll try to get you some resources to fix those issues, even if it's not here on one of the seminars. But again, we appreciate you guys joining tonight. Thanks to all our presenters for not only your time tonight, but agreeing to be on board with this here in the long term for the aluminum series, and helping connect a little bit more informal to our users and customers out there, and a way that we can hopefully fix a lot of your guys' issues. So thanks to you guys and your dedication to this as well. If nobody's got any other questions tonight, we'll end it there. But again, join us next week, and then keep your eye out on the different social channels, things like that on our website for future Shop Talk Live Aluminum Series episodes that will be coming up. There'll be a lot of different topics, and hopefully most of them will be driven by what you guys are looking to see. So we appreciate your time tonight. Everybody take care, and we'll see you on the next one.
Thanks, Travis.
Thanks, Travis.
Thank you.